Hello, my name's Stephen Pemberton. I'm talking today on the design of the URL. Well, this conference is being broadcast from the Science Park, Amsterdam, which was, as it happens, the birthplace of the open internet in Europe. In November 1988, 32 years ago just about, the first European open internet connection was established here with the incredible speed of 64 kilobits per second. Since then, it's nearly doubled every year and is currently peaking at 8.4 terabits per second, which is an extraordinary number. You can see it from the graph, the current throughput. It's interesting to see how in March, when the lockdown started, how it jumped up. But anyway, 8.4 terabytes per second represents a 27-fold doubling in the 32 years that it's been running. The introduction of the internet in Europe was an impetus for the creation of the World Wide Web. Tim Berners-Lee, who was working in CERN in Switzerland, wrote his proposal in March 1989, only a few months after the start of the internet in Europe. And his first web server was running in 1990, which he announced in 1991. It couldn't have been created really in a more international environment. He's a Brit. He was working with a Dutch-speaking Belgian with a French surname, Robert Caillou, and they were working on designated international territory straddling the Swiss and French borders. The World Wide Web cleverly combined several existing technologies that were around there. Technologies like hypertext, SGML, the internet, and created a successful global information system. There weren't a huge number of innovations in the World Wide Web, but one of them was the URL, allowing resources over the whole world to be identified for retrieval. Now, if you're interested, these slides are online. Here are links to several documents about early developments of the URL. There's the early design document from 1992, the first formal definition of URLs in 1994, the most recent definition, 2005, with some updates, internationalizing it, allowing more characters to be used, and an update for IP version 6. There's also a document there, interesting information about designing new URIs. So I said URI, I said URL. There are four terms basically being used. The original one was the Uniform Resource Locator, URL, which is there to locate and retrieve a resource. There's the Uniform Resource Name, which gives a name to a resource without necessarily specifying how to retrieve it, for instance, ISBN URNs. There's the URI, which is the umbrella name for those two things. And then finally, people also talk about IRI, which is the internationalized version of the URI, basically allowing a wider range of Unicode characters. So the structure of the URL, and as it happens in this talk, is that there are several parts, each with its own special characters, demarcate either its start or end. So it starts with the scheme, it's followed by an authority, then a path, then a query, and finally a fragment. And an authority consists of a user, a password, a host, and a port. A client uses a URL to retrieve, and I'm mostly going to be talking about URLs today. A client uses a URL to retrieve a resource from a server. It uses all parts except the fragment to retrieve the resource. The server itself only sees and uses the path and the query parts. And then when the resource is returned, the client uses the fragment in some way once it's got the document. The syntax of a URI is very general, and different parts of it may have different syntaxes. The URI specification itself only defines the characters that may be used for some of those parts, but not the syntax of all of them. Owners of the syntax of the other parts include the scheme definition, which tells you about the syntax of the authority and the path, the media type definition of a retrieved resource, which can define the syntax of a fragment. And it's not exactly clear who really owns the syntax of a query. Every single part of a URI is optional, though there are some combinations you never see in real life, such as leaving the scheme out but not the host, or retaining the scheme, leaving the scheme out but not, or retaining the scheme but not the host. In fact, even the empty string is a valid URL, and it means the current resource, and there are even some cases where that's useful. So let's now look at those individual parts one by one. So let's start off with the scheme. So the scheme principally represents a couple of things: the protocol that's going to be used and the default port number. Not all schemes have a formally defined protocol, or even a port for that matter. For instance, mail to and file depend on native properties of the client platform. There are some naughty applications, or naughty companies even, that specify schemes in order to just start applications up, and that's not what the schemes are about. Schemes are used for defining how to retrieve resources, and in general, it's the returned media type of the resource that should be used for initiating an application. Now, clearly, the most important scheme is HTTP. One obvious observation is that there's no real reason, in fact, there's no reason at all for the name of the scheme to match the name of the protocol that it uses. I think it's a great pity that they used HTTP instead of web as the name of the main scheme, because it would have made URLs look much more friendly. That HTTP looks technical right from the beginning. Later in this talk, I'll talk about the HTTPS scheme. Now, the scheme is followed by the double slash. The double slash announces the start of the authority, the name for everything up to the path. In other words, the user and password, the host name, and the port. If there is no authority part, then you don't need to use the double slash. The double slash tells you the authority is coming. Nevertheless, you do see a lot of people, or a lot of URLs of the form, for instance, file, with 3 slashes in it. And in fact, this is not necessary at all. File : / and the path is exactly the same thing. Why double slash? Well, in fact, any suitable character would have done to announce the start of the authority. It didn't have to be a double slash. It didn't even have to be 2 characters. In an early design document, Tim Berners-Lee reported that he took the double slash from the Apollo file system, where they needed syntax to differentiate the difference between a local file, like /folder/file, from a file that's got over the network. And they used a double slash at the beginning to show that the next bit was the name of the machine. What Tim Berners-Lee said was, when I was designing the web, I tried to use forms, syntaxes, which people would recognize from elsewhere, to make them familiar, I suppose. In fact, Berners-Lee has been reported as saying the double slash was the only thing he would change in the design of the URL because it's unnecessary. I tend to disagree, because it's useful to be able to distinguish between the machine, the authority, and the path. You need to be able to distinguish between something like http:/machine/file and http:/directory/file. The only way that this would work without a double slash or something similar would be to dictate that the scheme always requires an authority, which is not unreasonable in itself. It's kind of weird that there's place for a username and password in a URL. Bizarre, really, because both are exposed in any document containing the URL, and anytime they're passed over the connection, there's no secure method of transmitting them in the protocol. So you can also they can also be seen in the protocol. If you look at Berners-Lee's early design document, you can see that he mentions the username and password actually only for FTP. And so that's probably why they're in there, because FTP required a username and password to be able to retrieve a document. And if you didn't have a login, then there was often an anonymous login specifically for that purpose, which, and the username in that case was anonymous. So it's probably only there for FTP, but it's certainly not a good thing to use. I'll talk more at length about passwords later. The host part, the syntax of the host part was already a given in 1991. It had been defined for the DNS system in the mid-1980s, and so therefore was an obvious choice. The host part actually can either be a host name using DNS or an IP address. And an interesting thing about that is that since host names, computer names, can be a number, you might not know whether you're looking at an IP number or a DNS name until you've got to the last segment, and that's only because the last part, the highest level of DNS addresses aren't just numbers. Originally, the original web, the host part identified a unique machine. And machines weren't very powerful in those days. You probably needed a unique machine if you're going to run a web server. It was only realized later that several host names could point to the same machine, and that a single machine could easily host several servers. So that it's no longer necessarily identifies a unique machine, but the HTTP protocol had to be updated in order to support that properly, so that the server would know which server, which host name was being addressed. Since originally the host was identified as a single machine, many sites kept one machine specifically reserved as a web server. The first two URLs published in 1991, as far as I can tell anyway, were http://cernvm and //info. Interestingly, neither of them was called www. And yet within a short period of time, nearly all web server hosts were called exactly that, www. So that many people even thought that www somehow was an essential part of a URL, that they all had to start that way. In the same way that HTTP was a weird choice for the scheme name, www was a weird choice for the web server name, because www, with 9 syllables, www, is an acronym that's 3 times longer, at least in English, than the 3-syllable World Wide Web phrase it stands for. So it made URLs difficult to pronounce. Now, after the host name, there's a place for a port number. Each protocol has a default port, for instance, 80 for HTTP, but it doesn't have to be 80. You can put it anywhere you like on a machine. However, it's rather an odd place in the URL to put it, although from an implementation point, it's located on a machine. It's actually associated with a protocol. And it would really have been more sensible to put the port right at the front next to the scheme and say, well, we're using HTTP, but over a different port. Doesn't matter exactly what the syntax had to be, but something like HTTP-8080 would be an example. Now, a short sidetrack here. I want to talk about Endianism. If I write an address in the United Kingdom, it looks something like that. That was my address when I was growing up. What you can see is that there's almost entirely little Endian, from left to right, from top to bottom. The information gets more and more significant. Only the 21, the number, is big Endian. On the other hand, if you look at an address as it was in Soviet Russia, it looked like this, which starts with the word Russia, and then Moscow, and then the street, then the institute, and then the person's name with the family name first. So this is entirely big Endian. Now we're confronted with clashes in Endianism all the time. For instance, times are big Endian, starting with the hour and ending with the second, although we actually tend to speak times as Little Endian. We say 20 past 3. Dates, on the other hand, are Little Endian, except in the USA where they're just completely confused Endian. We inherited our number system from Arabic. And if you look at a piece of Arabic writing, such as this from the Wikipedia page on the Second World War, what you can see here is that although the text is read from right to left, all the numbers are still what we would call the right way round. So what you can conclude from this is that in the original Arabic form, numerals were Little Endian, which actually has some slight arithmetical advantages, especially if you're doing additions in your head. But they were imported into Western languages exactly as they appeared in Arabic, in other words, back to front, and so became Big Endian. It's interesting to note that historically, before the introduction of Arabic numerals, we spoke numbers, at least under 100, in a Little Endian form. 16 starts with the word 6. 4 and 20 blackbirds baked in a pie. The time is 5 and 20 past 3. These are examples of how numbers used to be spoken. Arabic numerals were introduced during the Enlightenment, which may have affected how we spoke numbers, since now, in any case in English, we speak numbers Big Endian, with the exception of the teens, basically between 13 and 19. In fact, Shakespeare used both styles of numbering. I did a check. I looked through all his plays, and I found that he used the old style Little Endian numbers like 4 and 20 about twice as often as Big Endian. So that may indicate that it was around his time that numbering was changing. Although, of course, you have to also take into account the requirements of the meter. So he may have chosen one form over the other just to make the meter better. Anyway, the whole point of this Endianism discussion is that at the point where the authority ends and the path begins, the URL shifts from Little Endian to Big Endian, because something like www.example.com is Little Endian, starting from low information going up to high information, whereas the path starts at high information going down to low information, so it's Big Endian. Berners-Lee has pointed out in the past that he would actually have preferred to have had the authority part Big Endian, and he gives an example where he uses com/example/www. This does have a problem. It's hard to locate where the authority ends and where the path begins. Could even be ambiguous, so it's not entirely good, but the point is well taken. So then we've got the path. It suggests a file path. It looks like a Unix file path, and indeed in the first implementations and many current implementations, it is indeed so. But it's not a requirement that it be a file path. Officially, the path is opaque. That is to say, you're not allowed to conclude anything from it. For instance, there's no a priori reason why /2020/talks and /talk/2020 shouldn't refer to the same thing. They could refer to the same thing. There's nothing to prevent that. It's interesting that at the end of most URLs, there's a file type like index.html or logo.gif. And that this reflects indeed that many implementations map a URL directly onto the file store. And then they use that file type for returning the media type to the client. In some respects, this is a pity because it means that we lose out on a great and underused property of HTTP, which I now want to talk about. It has a number of headers that allow you to characterize properties of the resource that you're interested in. It's called content negotiation, although there's actually no negotiation actually going on. The sorts of things that you can specify, the sort of properties you can characterize are the language, which natural language you prefer, and which ones you will accept. Document type, which you would prefer, whether you prefer HTML or PDF or whatever, and which ones you're still willing to accept. the character set and encoding, and the compression types that your machine can deal with. Now, the latter two are more for machines, so I'm not going to talk about them, but the first two are definitely useful for people. So let's talk about accepting the type. If a page specified a logo, an image, just using the name without having the specific type at the end, like .gif, then the client program could include an accept header of all the image types that it accepted, listed in the order that it preferred them in. And the site could then have several versions of the logo available for sending back for different preferences. Similarly, if a site had a document available in several different types, the client program could list them in preference order. Or a machine could even check if a particular type was available by just saying it only accepted that one type. So if you had a document called declaration, you wouldn't have to say that it was .http or .doc or .pdf or whatever. You could let the client specify which one it would rather have. Except language is similar. Many sites offer their content in a variety of languages, and almost always you have to click to select the one that you would like. And yet the annoying thing, or at least it annoys me, is the HTTP protocol allows you to say which languages you prefer and which ones you will accept. So the site doesn't really need to ask you this. Google is in fact particularly really bad at this. If you take your laptop to a different country, their interface suddenly switches to the language of that country or one of the languages of that country, even if your browser is telling them which language you prefer. And the worst case of this is me catching the international train from Amsterdam to London, where I got the Swedish interface to Google, presumably because of the internet service provider that the international train uses. This shouldn't have to happen. The browser can say to the server which languages to serve. One of the problems, of course, and why this facility is so underused is that it's not exposed in the URL, these features of HTTP, which is in a way a great pity, because it would be really useful if you could say you specifically wanted the PDF version of the document in Dutch, for instance. And I mean, I've invented the syntax here, but it's not unreasonable. Or that you preferred PDF, but you're willing to accept anything they've got, and that you could give a couple of languages. These facilities are available. It's not available in the URL, and that's a shame. Another shortcoming of servers that do accept the accept headers is that when they return something that doesn't match up with what you've asked for, they don't give you the right response code. You usually get a 200, which just says everything's okay, here's the document you asked for. When in fact there are response codes that tell you, well, I didn't find anything acceptable, but here, have this anyway. It's not quite as bad as returning a 200 when you should get a 404. But it's close to as bad of it, because it would be great to be able to write a program that would discover what a site offered in terms of languages and document types. After the file path, we've got the query. The query allows you to send a small amount of data with the URL rather than in the body of the HTTP request. The major design blunder of the URL for HTML was using an ampersand to separate the values that get sent, since the ampersand is a special character in HTML, so that you can't just paste a URL into HTML, but you have to edit it and replace every current occurrence of an ampersand with ampersand amp, semicolon. They realized later that they'd made this mistake, and they tried to fix it by saying, well, a semicolon is also suitable. But it was too late, and nobody's really adopted that. There's another weirdness of the HTML query as well, that spaces should officially be replaced with a plus, which means that a plus then has to be replaced with %2b, even though in other places a space is replaced with %20. It's kind of weird. I'll talk a bit more about this later. The final part of the URL is the fragment. the fragment's used after the resource is retrieved. Its syntax and how it's used is up to the specification for the media type of the resource returned. Even though it's sometimes called a fragment identifier, and for HTML it must be an identifier, there's no syntactic requirement in general that they be identifiers. And it's, as I say, it's up to the media type to say what the syntax is. Berners-Lee reported that he uses the hash sign because of its similar use in postal addresses in the USA, indicating a sublocation of an address. So, as we've seen, a URL uses a number of special characters for its syntax. In order, the colon used in 3 different places for the end of the scheme between the username and password and the start of the port. Double slash to signal the start of the authority, @ to signal the end of the user password, slash to signal the start of the path, question mark to signal the start of the query, and hash to signal the start of the fragment. There's a general rule in the syntax of a URL that to the left of the last official use of the character in the URL syntax, if you've got to use that character, then it has to be encoded. And if you have to use it to the right of the last official use, it doesn't have to be encoded. For instance, a colon in a password has to be encoded because a colon can come before the port, but it doesn't have to be encoded in a path. Similarly, a question mark in the path has to be encoded, but not in the query or the fragment. There's one mistake though, it doesn't count for hash. They must have missed this out. Even in a fragment, a hash has to be encoded. Now, let's talk about encoding a bit. The web and URLs were defined pre-Unicode and used Latin 1, which was already better than the rest of the internet at that time, which used pure ASCII. For instance, DNS is pure ASCII. Unfortunately, so Latin 1 is an 8-bit character set. Unfortunately, they defined the method for encoding a character as just an 8-bit encoding. So there's no terminator, it was just 2 hex digits for 8 bits. So spaces, for instance, %20. This meant that when longer characters than 8 bits came along in Unicode, there was no way to encode them in a URL. Ideally, you just use the code point for that character, but you can't because there's no way of writing it down. So if you wanted to do a search for on a heart, although you'd ideally just want to specify you're using that code point, you can't, and you have to encode it first in UTF-8 and then encode those bytes using the URL encoding. It's a great shame. It's notable that spaces do not occur anywhere in a URL and may not occur anywhere in a URL. And Tim Berners-Lee says that that was just because in the old days in mail, a URL might get split, and so there should be no white space in URLs so that you don't lose the detail. It also means that you can have data types that consist of space-separated lists of URLs without any problem. As I already mentioned, there's that one weirdness that within the query, spaces should be encoded, or at least in HTML queries, spaces should be encoded with plus rather than %20. So having got to the end of the URL, let's now go back to the beginning and talk about a couple of issues. Firstly, HTTPS. HTTPS is a mistake introduced by Netscape along with a number of other mistakes that they made, such as the blink tag, their design of the image tag, and the frame tag. Frankly, the two URLs, HTTP whatever or HTTPS whatever, locate the same document in every way. The only difference is in the details of the protocol being used to receive the document. In other words, whether the connection is encrypted or not should be part of the protocol and not part of the scheme. We as users shouldn't have to care about nor be confronted by the negotiation between the machines about how they're going to transport the data. The machine should just say, well, I accept encrypted communication, do you? If the answer is yes, then they can just carry on encrypted. We don't have to put that information into the URL. We're now being forced to change all our documents to use HTTPS links in order to make the web safer. And that shouldn't have been necessary. We shouldn't have to change our documents to make the web safer. And now the last bit, passwords. Unfortunately, passwords were not properly part of the protocol. Basic authentication, which we've already talked about, the username password in the URL, is of course terrible and should be ignored. Nowadays it's done. Every site has to organize a password system, and its rules for passwords, which are different of course per site. And it also requires every site builder to understand the fine points of passwords and how to store and protect them sufficiently, which frankly, many don't. This has meant that the web is a royal security mess because we have to remember so many passwords, and so many passwords get revealed because they don't get protected properly. So I want to talk about how this could be fixed using the protocol. So to get us on the same page, let me just give you an overview of public key cryptography. Everyone has two matched keys. One is public, anyone can have a copy, and one is private, which only you have. You can lock a message with either key, making it unreadable. If you lock with one key, only the other key can open it. That's how it works. Now, keys, when I say keys, it's actually a very large number, 300 digits or more, and locking means scrambling the message using those large numbers, but it's keys and locking. So, identity. If I lock a message with my private key, so it can only be opened with my public key, if I send it to you, you get a copy of my public key and open the message. If it works, you know it was really from me because I'm the only person who owns my private key. So you really know it's from me. So this would be great because you couldn't get no more spam, for instance, because if you were sending messages using this method, you'd know it was really from the person who said it was. You can also get privacy. If I lock a message with your public key, so that can be only opened with your private key, I can send it to you, and I know that only you can open it to read it. And I can combine these two things. I lock a message once with my private key and the second time with your public key and send it to you. You know it's really from me. I know only you can read it. Perfect. So how can we use this for passwords? We can use the same process when logging into websites. Let me explain it. And this could just be added to the protocol. You want to create an account at an online shop. So you click on create an account. The site asks you for a username. You fill that in and you click OK. The site checks that username is available and returns a message to your browser that you want to register. The browser asks if you really do. If you click yes, then the browser and the site exchange public keys without any more work from you. Then when you want to log in, you fill in your username and click on login. The site generates a one-time password, locks it with your public key and its own private key, and sends it to the browser. The browser knows it's really from the site, it's not somebody pretending, and it asks you if you really want to log in with that username. If you say yes, it decodes the password and sends it back to the client, to the server, this time locked with your private key and the site's public key. The site knows it's really you, and so can let you in without you having to type any password. This isn't anything new. This is how SSH works, for instance, when you're logging into remote machines. It would get over all the problems, the current problems of passwords, and make the web that much easier to use because you wouldn't have to have different passwords for every website. So my conclusion in general is URLs have been extremely useful. They're a part of daily life now. There are some clear design faults that would be better if it had been done slightly differently. That's easy to say with hindsight, but that can be lesson for us for future designs of any notations we want to do.